We're going to continue our line of best fit by looking at predictions based on that model. So we have data. We know that today is going to be scattered. There's a little bit of variance, a little bit of a change that's happening from one person to the next or one situation to the next. But we can use that data to help us create a model. That's what our line serves as. So if we have that model, we can then make predictions on other people or other situations based on that model by making predictions using that equation. So here we have the scatter plot shows the total number of hours that people rented a bike and their total cost. Based on the line of best fit, what do you predict the total cost would be for an 8-hour rental? How long could you rent a bike for a cost of $10? So notice we have our scatter plot, and they've done a great job of titling our graph and labeling our axes. So we see that we have time in hours versus cost in dollars. We're going to draw a line of best fit, and we're going to write an equation. I'm going to start off by doing just like we did last time, which is taking my ruler and trying to eyeball in where I see. Now notice it's a very strong relationship, so I really feel like I can kind of split those points and be able to get a line of best fit. But I want to find these grid marks that it's going through so I have points to work with. So this one looks like a pretty good point right here, and maybe that's kind of, I almost feel like I can use that y-intercept down there. Maybe not quite. All right, this one might have to be a little trickier, and we might have to use decimals because I think this will probably work. Okay, so this point right here I'm going to use, and this point right here I'm going to use, and I'm going to connect those dots. Now remember, I'm going to show you another method that allows us to use the computer and get a little bit more exact than what we're able to do right now by eyeballing it and trying to find points. So this point here was 6:24, and this point over here was 2:12. So as we did before, we're going to use y minus y1 equals m times x minus x1. I need to get my slope, so I'm going to come over here and find my slope. M equals 24 minus 12 over 6 minus 2. 24 minus 12 gives me 12. 6 minus 2 gives me 4. And 12 divided by 4 is 3. Much nicer slope than we had before. So y minus 24 is equal to 3 times x minus 6. Then I'm going to change that into slope-intercept form. So I'm going to distribute, and I get y minus 24 is equal to 3x minus 18. Then I'm going to add 24 to both sides, and I get y is equal to 3x plus 6. So my equation in slope-intercept form is 3x plus 6. Wow, that writing came out funky.